So today's lecture is going to be of two parts. It's gonna be something similar to what we did last time, although I think the topic today is going to be way more interesting. So today we're going to do, we're gonna learn about cryptography and encryption, hashing, those type of things. Okay, so as I said, we're gonna have two parts. First part is going to be I'm going to explain the process on how you can encrypt and decrypt messages, what is hashing, how you can do it, what are the different types of encryption, how to build a signature and how signature work. And after that, we are going to build some code based on that using Python. Okay, so this code that we're going to be writing today and the exercises that we're going to be writing today are going to be applicable for your assignment, which I'm also going to release today. And of course, we can talk about it as well. Okay, so firstly, I'll go to the theory, then we're going to move to practice, and then you will see how the practical exercises that we do are going to be linked to your assignment. Sounds good? Okay, so as I said, today we're going to talk about cryptography, which pretty much defines how we're encrypting, decrypting, hash, or pretty much how we send information over a medium in a secured way. Okay, so here you can see some different security services that are ensured by the cryptography and the methods and mechanisms that we're going to use in order to achieve those. Okay, so we have confidentiality, which is achieved with symmetric encryption. We have authentication achieved with digital signatures and digital certificates. We have integrity, right, which is mainly achieved with hashing, but also with encryption and decryption. We have non-prioritization achieved with digital signatures, and non-reply, which is achieved with encryption, decryption, hashing, and digital signatures. Okay, so I know that some of the terms you might heard, but most probably you don't know how exactly they work. So we're going to clarify the things a little bit today. So before explaining how the encryption actually works, let's first see the different components of some cryptographic system. Okay, so as you can see here, firstly we have a plain text. This is the message that you want to send. Then we have the cryptographic system. So inside the cryptographic system, something happens. So there is some algorithm or code that is modifying the plain text, and once the plain text passes through the cryptographic system, then we get the ciphertext, okay, which is some, you can imagine it as a code or something that you don't understand, that is the encrypted text. Okay, and there is also one other very important thing here. This is the key. Okay, so what is the importance of the key when we are encrypting messages? So for example, if we have, imagine we have two senders and receivers that are from the same city, right? So one sender wants to send the message to a receiver, and the other sender wants to send a message to another receiver, right? So if we don't use keys, if sender 1 sends the message hi, and this message gets encrypted with a cryptographic system, okay, and let's imagine the sender B sends exactly the same message, and the message is also encrypted with the same type of cryptographic system, right? Then we're going to get exactly the same looking encrypted message, right? Which is not acceptable because there will be a confusion. For that reason, it is better if you have some key or some other parameter that is specific for the communication between the first pair of senders and receivers, and the second pair of sender and receiver have a different key. That way, no matter what type of messages they exchange, the ciphertext is going to be different no matter what, because the keys are going to be unique. Also, having key can really help us to have something very specific, and this is why it's a key, because it can encrypt, so it can lock and unlock the message that you want to send. So it is worth it to have a key unique for every communication or for every user, and you'll see how keys work. They're actually two main types. Okay, so those are the main elements. Now, but how the messages are getting encrypted, okay? How we're processing them. So there are actually two main types with which we're creating the ciphertext. So the first one is called the stream cipher, which is not that used these days, and the other one is called block cipher. Okay, so the stream cipher, you can imagine it as when you send the message, simply you put the message into bytes, you encrypt this stream of bytes, right, and then you send it. This is not as secure, and for this reason the block cipher was developed, and the block cipher is dividing the message into smaller blocks, right? So each block can be of certain size, okay? Normally in many algorithms this is 8 bytes, okay? And each block is then encrypted and sent. Of course, if you have blocks and they are encrypted separately, this is more secure than if just encrypt the whole stream of bytes. Okay, so this is why we're actually going to talk only about the block ciphers, because this is what we're using these days. Now, we can go even further from there. Okay, so once we have a message separated into different blocks, okay, there are two options. One of the options, the less secured one, is to simply encrypt each and every block. So each and every block, we pass it through algorithm that is going to encrypt it, and we send it. Okay, and this is called electronic code block. Okay, now the other 3 blocks are related. Okay, and the basis of them is that every next block that is encrypted depends on the previous one. Okay, so once we encrypt block 1, okay, we take some parameter from that encryption, and then we use this parameter as a key, you can imagine, for encrypting the next block. This is how you know that all the blocks are related. Okay, so you can pretty much cannot decrypt block 2 without having block 1. Okay, so there is no way to decrypt the blocks individually, right? Any questions so far?
Is that where I guess you get the idea of the blockchain that I hear frequently, like with Bitcoin?
Yeah, so yeah, there you also have separated blocks, of course, but yeah, so they have cryptographic algorithms they use there, of course, that they are used in the in encrypting messages. So yeah, you can say that. Yeah, it comes all from here, right? So the blocks, they are very basic encryption theory, right? So for sure, I think the name comes from there. So, you know, now once we have those blocks, now let's talk about what we do in order to encrypt each of those blocks, right? So there are again 2 main practices to do that, and one of them is again way less used comparing to the other. So when we want to encrypt something, okay, we can either do asymmetric encryption, okay, or we can do a public private key encryption. Now, what's the difference between those? In the symmetric encryption, the sender and the receiver, they have one secret key each. Okay, so the receiver will need to have the secret key of the sender in order to decrypt the message. Okay, so this means that the key of the sender needs to be sent to the receiver as well with the message, so the receiver knows how to decrypt it. Okay, while in the public-private key encryption, okay, the sender and the receiver, they both have two keys. So the sender has public and private key, and the receiver also has public and private key. And later on, I will talk a little bit more about the public encryption, public key encryption. But first, let's talk about the symmetric, because it is a more simple one. Okay, so we're going to talk about the advantages and the disadvantages. So this type of encryption is still used those days, but it's not that common, and you'll see why. So here, as you can see, we just have the most basic scenario. So we have a plain text, we have encryption algorithm, we have ciphertext, then we have decryption algorithm, and finally we again get the plain text. Okay, so also, as I said, the sender and the receiver, they need to exchange keys in order for both of them to be able to decrypt their messages. Okay, so let's discuss this. What do you think can be a disadvantage of this type of algorithm? Any ideas?
Of the symmetric encryption or the key encryption?
Yeah, the symmetric encryption. What would be a disadvantage?
Well, if you figure out what the cipher is, then you can get the message.
Exactly, yeah. And it is quite risky sending key over the internet, right? So you send your key to the receiver, but along the way somebody can pick this key up, right? And if this person has the key, obviously they can decrypt any message exchanged.
Yeah.
Right?
My question with a lot of this is, I guess, that how is it that when you have the public and private key, how does everybody get the key that they need to have?
Yes, good question. And let's get to there first, okay? And I think when we go to the public-private key part, I think you're going to answer this question for yourself, okay? So let's see. But for now, we're talking for the symmetric encryption. So now, in the symmetric encryption, obviously, as you said, the first disadvantage is that somebody can steal our key. Another very big disadvantage is, for example, imagine if you want to communicate with 1000 people, which actually is quite common these days because your laptop communicates with multiple applications at the same time. So your laptop will need to keep track on all the keys from the directions that they communicate with. So if I communicate with 1000 applications, I need to hold 1000 keys, right? Which at some point it becomes a problem, especially if you have big networks, right? So this is one of the biggest disadvantages of this algorithm, and this is why it is not quite preferred these days, especially with the expansion of the internet. So now here on this slide I put one of the algorithms, the DES algorithm, that is used for symmetric encryption, okay? And also here you have a table of the different symmetric algorithms, you know, and what is the length of their key, okay? So this is a pretty standard scenario, a little bit more complex than our example, okay? So usually you would have 16 circular key shifts, okay? So the key, so the numbers on the key or the digits will change from time to time in order for this key to be more secured, and this will need to constantly be exchanged between the user, between the sender and the receiver with this algorithm, Okay, so even though, for example, with the DES algorithm, let's say we have all this process that you can see here for communication that makes it harder to break down the algorithm, still you can see that the key is 56 bits, right? So if the key is 56 bits, this means that somebody can just try different combinations, okay, of those 56 bits and guess the key at some point, right? This is also possible. So for this reason, even this type of algorithm, of course, is not that secure. Now, here I also listed some of the disadvantages that we just discussed of the symmetric encryption. Again, those are the fact that somebody can get your key, also the fact that you need to maintain multiple keys at the same time, and so on. So those problems really need to be addressed, and one way to do that is the public key encryption. Okay, so let's talk about this a little bit. Now, so you asked about how, so if we have a public and private key, how the whole process works, right? So now you can imagine the public key. So as I said, the sender and the receiver, they both have public and private key each. Okay, so you can imagine the public key as a mailbox. So let's say you have your public key, this is your public address, so you have the mailbox there. Okay, so if somebody wants to send you a message, this person is going to drop the mail to your mailbox, and then you have your private key, which is opening the mailbox. Okay, so this is the whole idea behind this algorithm. Now, there is also another scenario where the sender might leave the mail in their mailbox. Okay, but you can open this mailbox with your private key. Okay, you'll see how this works in a second. So let's see the first scenario. Now, let's say A wants to send a message to B. So here's how the process works. So A will encrypt the message with B public key. Okay, so this is the same as putting the key into B mailbox. Okay, then B is going to go to their mailbox and they're going to decrypt the message with their private key. Okay, so this is how we open the mailbox and actually reading the actual message that A sends. Okay, so after that, if now B wants to communicate with A, B will encrypt the message, right, with the A public key, because it's public and B knows it, and then it will send it to A, and then A will decrypt that message with the A private key. Okay, so this is the idea. Now, doing this strategy using public private key ensures two things. So firstly, it guarantees, okay, that A for sure delivered the message to B, right? Because A used B public key. So they put it in B's mailbox, right? And also we ensure confidentiality because the message was encrypted and probably hashed, so we're also confidential. Now, here it comes the problem. Even though the message is in a B mailbox, okay, and it says that it comes from A, B cannot guarantee that this message actually came from A, because B address is public address. Okay, so everybody can put a mail there and it can say I'm A, right? So B cannot guarantee that the message came from A, even though the message claims that it came from there. So to fix this issue, we can do the following. A can encrypt the message M with a private key. Okay, instead of with a public key. So once we A encrypts the message with the A private key and send it to B, then B can decrypt it with a public key. Okay, so what this means? This means that now B can verify that the message came from A because A encrypted it with their private key. So since only A has their private key, we for sure know that the message came from there. Okay.
Can we use both our private keys, Professor?
Yes, exactly. We're getting there. Exactly.
Okay.
So this is the whole point. So now the problem here is, even though that B knows that this message came from A, now A is not sure if B got the message, right? Because A encrypted it with their private key, okay, but it didn't actually send it to the B mailbox. But you can imagine this as A left the message in their mailbox and then B came and took it, right? But A cannot verify that B actually took the message. Maybe somebody else took it, right? Because remember, the A mailbox can be opened with the can be checked with a public key, for example. So now we have two situations where in one situation A can verify that the message has been sent to B, and in the other situation B can verify that the message was sent from A. So in order for us to be good on both sides, so both A and B are authenticated, we will need to do double encryption. Okay, and here's how it works. So what we're gonna do is, firstly, A is going to encrypt the message with their private key. Then A is going to encrypt again the message with the B public key. Then we will send the message to B, okay, and firstly B will decrypt the message with the A public key, and then B will decrypt again the message, so the result with the B private key. Okay, so that way it's like opening an envelope inside an envelope. And finally we're going to get the message, and this way we're 100% sure that the message came from the right source and was delivered to the right address. Okay, any questions? Make sense?
Yes, Professor.
Okay, sounds good. Okay, so what are the problems with the public key encryption? So although it is way more secure comparing to the symmetric key, there is one disadvantage, that obviously the public key encryption takes more time, because we're doing 4 times. So we do 2 encryptions and 2 decryptions, right? Using 4 keys in total. So obviously it takes more time. And for example, the symmetric algorithms, they just use 1 key. So they're just encryption, decryption, that's it. So they're faster. Okay. So now another thing is where we can use the public key encryption algorithms, right? So since they're secure, you can really authenticate the sender and the receiver. You get message integrity, so you're sure that the message haven't been modified. For that reason, they are the most used, and actually I think this is the most used type of encryption for communication through internet, right? So if you go to a page, if it is HTTPS page, this means the S is the SSL algorithm, which is a public key algorithm. Okay, so this is used everywhere. Now there is still some problem here that we need to talk about, and this problem is a problem with the key exchange. Okay, so we already discussed that in the symmetric key algorithm, obviously, when we send the key through the internet, this key can be modified, right? So this is a problem for the symmetric key exchange. Now, with the public key exchange, we also have some problem. So obviously, if A has a public and private key and they want to share their public key, how do we guarantee that this public key is in fact a public key, right? How do we ensure that? We need to have some authority that is going to verify that a public key is belonging to A. So there are two types of authorities, right? So one is called the KDC, which is the key distribution center, and this is the authority responsible for the symmetric keys. For the public key cryptography, the authority is called certificate authority, or CA. And we're going to talk about those now, so you understand how we can ensure that keys generated are in fact belonging to the right devices. Okay, so the first one that we're going to talk about is the KDC. Okay, so the key distribution center, and this center is used for generating symmetric keys. Okay, so on this scheme you can see how it works. So if this circle is the sender and the other one is the receiver, what the sender needs to do is firstly to request, so it needs to request from the key distribution center the session key and the B secret key. Okay, so the session key is a key that is created once A wants to communicate with B. So when we start the session, we create a session key. Okay, B secret key is obviously the key that B has for encryption, since now we're talking about symmetric encryption. Okay, so after that, this key distribution center, which has data for all the secret keys, is giving to A as a response the session key and B secret key. Then A sends a message to B encrypted with the B secret key, right? Then once the message arrives to B, now B maybe wants to communicate with A again. So B will ask the key distribution center, hey, can you give me the session key that you established with A already, and also can you give me the A secret key? And the distribution center is giving the key to B, right? So once now both parties have their secret keys, now they can communicate and exchange messages. Okay, so this is how the key distribution center works. And again, I want to emphasize this is for the symmetric keys. Okay. Now, more interesting is the situation with the public keys, right? So here we're having, as I said, a certificate authority, which has the role of binding the public key with the identity of the person that is that wants to send a message, right? Okay, so in general, there are actually many ways with which we can keep track on the public keys when we do, public key encryption and decryption. So, for example, we can have a public announcement of all the public keys of all the devices, right? We can also have some public directory that is trusted, and everybody can go to this directory and check for the public keys of all devices. Okay, but this is all incorporated in the certificate authority. Okay, so the certificate authority distributes the certifications, and a certification consists of the public key, some details for the identity of that device that has this public key, and a signature. So since this is a certificate, right? So since each device has a certificate, it needs to be signed. Of course, everything happens in a digital way. So the signature is some verification that in fact this certificate belongs to the right person. okay, and we'll see how this actually works. Okay, so this is a typical way on how a certificate is going to look like. So you can see that we have the version, serial number, some information about the issuer, so who issued this certificate. Also, we have a validity of the certificate, for how long is it valid. Okay, and here's, for example, the public key information, right? So this would be the public key, okay, and you can also see the signature, which is right here in the bottom. So obviously this is not like a typical certificate that you would imagine, right? You can see all different bits here, but in fact they guarantee the authenticity of this certificate. Okay, so any questions for the certificates, how they're distributed, those type of things? Okay, so lastly, before jumping into hashing and how signatures are actually made, because I think you maybe ask yourself, okay, but how we really ensure that we're having the right signature, like how is a signature made? So you might want to know that. But before that, let's just first talk about the public key infrastructure, which pretty much involves all the personal software algorithms that are distributing and creating the public keys. So obviously, if you're on a network with multiple devices, all of them, they need public key. They're going to contact this authority, the public key infrastructure, okay, which, you know, creates the keys, creates the certificates, holds and distributes them. Okay, so now once we know about this, let's go a little bit further. Okay, so how we actually ensure that the messages that we exchange are the correct ones, they have never been changed but by anyone along the way, and also how do we verify that a message is sent by us, you know, by signing it. Here it comes the hash functions. Okay, so how is, first of all, hashing different from encryption? Can somebody tell me? I mean, if you've heard or if you know. Okay, so there is so first of all, both encryption algorithms and hashing algorithms, they're creating, so they're breaking down a message into a code that you cannot understand. Okay, both of them, they're doing that. The difference is that hashing is irrevertible. So once your message passes through a hashing function, then from the hashing message, so from the message that you get, from the result, you cannot get back the previous message. Okay, you cannot revert it. It's one-way function. So once you hash it, that's it. You just get a code out of it. It cannot be reverted back. In the encryption, you can always encrypt the message and then decrypt it, so bring it back to the original form. With hashing, it's not like this. So why do we need hashing? So you're going to see right here. So we need hashing to verify that the message that we sent haven't been changed. The hashing algorithms these days are, especially the last one, like, so before we had the MD5 algorithm, which now is considered broken because it can be reverted. You know, a hashing function should not be able to be reverted. But we also have the SHA-3 algorithm that is now the most popular hashing algorithm. Okay, so another very important part of the hashing is that even if you change one full stop inside your message, the hashing code is going to look completely different. Okay, so it is not like if you change small detail from the message that the hash message is going to be similar. No, it's going to be something completely different. Yes, somebody raised a hand.
Yeah, Professor, this is Sri. So what if we miss the message, one message, so it doesn't get the key, and how we decrypt the next message?
Oh, good question. Okay, so how that works is, let's say if you want to transmit a message, right, and let's say this message has been altered along the way, or parts of this message have been changed, and let's say we receive the message, the hashing doesn't, it looks different. What do we do then? So yeah, so in most cases, then this message is thrown to the garbage. Okay, it's thrown away, and we try to resend the message automatically. Okay, most systems, if you're having to send the same packet multiple times, then there can be some algorithm that is saying, okay, now stop the connection because something is going wrong, right? I'm sending messages and they get received and they look different, so stop the communication, something is going on here. So this is the way that this is how the communication works, and if a message has been altered along the way, then it is being discarded and try to be sent again. Now, if you are using, for example, in transport layer, if you're using QDP protocol, you're just going to discard this message and you will not try to send it again. But if you're using, for example, the TCP protocol in the transport layer, you're going to be trying to send it again and again and again. If eventually you're not able to send it using TCP protocol, then the whole so if you are trying to send the file, for example, the whole file that you try to send is not going to be sent, because for a TCP you need all the messages delivered to the address, right? Okay, is this answering your question?
Yes, Professor, thank you.
Yeah, no problem. So how digital signatures work? Okay, obviously they use hashing. So if I want to send a message to somebody, I'm going to do two things to ensure that exactly this message goes to the receiver. So firstly, I will send the message as it is. Let's skip the encryption. Obviously we're going to encrypt it, that's clear. Let's forget about the encryption for the encryption for a second. I'm going to send the original message, okay, but also at the same time I'm going to pass this message through a hashing function, and I'm going to get a code, right? So I'm going to send the original message and the hashed message, right? Both of them, I'm going to send them to the receiver. Then the receiver will receive my original message, right? But before reading it, okay, in the background, what he's going to do? He's going to take the original message and pass the same hashing function through that message. And he will get a code. And then he will compare this code with the hash code that they received from us, right? So if the codes match, what that means?
Then it means the message has not been altered.
Exactly, that the message haven't been changed, because we get the same code. Even if we change, as I said, one dot in the message, then once the receiver gets the message, they'll get a completely different code, right? And this is how we're these are the essentials of the digital signatures. This is how they work. Okay. So this was, guys, the theoretical part of the lecture today. How does it sound? Did you understand pretty much how it works? The encryption, hashing, digital signatures, more or less?
It gave us a rough idea, Professor.
Okay, good. So that's good. I wanted to give you a brief idea, because now we will start coding, and I will show you two scripts. One of them is going to be for encrypting a message using Python, and the other one will be for hashing a message, again using Python. Okay, so let's get started. Again, all the files from what I'm going to show you right now are going to be uploaded on Blackboard, so you can just open this, you can just open them and follow along, or you can follow exactly the same methodology that I do right now and just write the code together with me. It's up to you. Okay, so to write the code this time, I'm going to use a website called replit.com. Have you used this website before? I know that some of the other professors, they're actually using it when they're writing code. So yeah, I hope you know it more or less. But even if you don't, it's very easy to use. Okay, so here I already have an account. So obviously, once you create an account, this is going to be your dashboard. Okay, so if you want to create a Python project, you can just click create new repo. Okay, then select Python. Okay, and then you can create it. Now, why I'm using this type of tool? This is because for this project, what we need to do is to install a package, okay, that is a third-party Python package in order to be able to encrypt messages. Okay, so once I'm here, you can see I have my main file, and then here you have shell. Okay, so in the shell you can install different types of libraries that you need in order for your project to work. So here I will do pipe install. Okay, and then I will install the library that we're going to use, which is called Cryptography. Okay, so this library is now installed. Then what I'm going to do is I will create two files. So one of them is going to be called encryption. Okay, encryption.py. Good. And the other one is going to be called hashing. Oops, I had to do hashing. So make sure that you do .py so it notices that this is a Python file. Okay, hashing.py. Now the first example I'm going to show you is for hashing. It is very simple. All right. So now here in this file you can type. Firstly, you can import the hashing module. So I will do import hashing. Okay, and once we have this module, for example, you can ask the user to write a message, and then you can hash this message, right? So I can do, for example, hashed message equals, okay, and after that let's do hashing dot, and here you can choose the algorithm that you want to use. Okay, so for example, actually this is a hash lib. Oh, and this is hash lib. Yeah, that's the right one. Okay, so here you can define the algorithm that you want to use. Okay, and as I said, a very popular one is the SHA algorithm, and there are different versions. I'm going to use the SHA 256. So this is the algorithm with which we're going to hash our message. Okay, and after that I'm just going to write the message here. So message, I mean, we need to create this variable, and then here, okay, I will write hex digest. Okay, that's good. Now obviously here we're getting an error because of this message. So we need to create it. So I'll do message equals, and again we're going to do here input, and let's write to the users, enter the message to hash. Okay, and once we do that, we're going to write in code to encode the message in bytes. Okay. Oh yeah. All right. So what we did so far, we asked the users to write a message right here in this line, and after that we hashed this message. Okay. So now let's just print both. So I will just write print original message. Okay. And then we're going to put the message and write the code. Okay. So we encoded the message right here in order to be able to push it into the hash function, and then we're decoding it in order to be able to display it as it was. Okay, and now let's display the hashed message. So obviously this is going to be this one. So I will just copy and paste this so we save some time. So here we have the hashed message, and here I will also write hashed message. Okay, so pretty much you can see that the rest of the lines are pretty much helper lines in order to add the input and then to display to the users. But how you can hash a message using Python is using this function right here. Okay, so obviously this is important to remember for the assignment, because there I will ask you to hash certain things. Okay, now let's run this. Actually, let's see if it's gonna just run the main file or this file. So it's running this file. So because of that, I will just put my code in the main file. Okay. Let's run it. So you can see here, now we're on line 3. It asks me enter the message to hash. So let's say I can write the sky is blue. Okay, and when I click enter, this is our original message that we wrote, and this is the hash. Okay, so I will just copy this hash right here, and actually I'll copy this output because I want to show you that if I change very small bit of this message is going to look completely different. So we can test that as well. Okay, so I'm just copying it so you can see the previous hash. Now let's run the code again. Oh, it actually saves it here, that's good. Okay, so let's put exactly the same message, but I will just change a very small part of it. Okay, let's try like this. The sky is, so I will just keep the E. Okay, and let's see what we're gonna get now. So you can obviously see that this hash is definitely completely different from the previous one. Okay, there is not a single match. And as I said, when we want to exchange messages, we're going to send the original one and then the hashed one. Okay, and then once the receiver gets the message, they will run exactly the same hash function through this message, and we'll try to match exactly the same hash that is here. Okay, any questions? Or I think it's pretty straightforward, right? It's just on one line that we do this. So okay, nice. So now, once we're ready with that, I can show you how you can actually encrypt messages, right? Okay, it is also very simple. It takes a few lines of code, obviously, because here we have to encrypt and decrypt a message. Also, I will show you how you can generate a key for this purpose. Okay, so here in the encryption file, I write from cryptography dot fairnet import fairnet, and fairnet is a class that is used to create key. Okay, so let's do that. So firstly, let's do key equals to fairnet dot generate key. Okay, so now we generated a key that we're going to be using for encryption and decryption. Okay, so now once we have the key, we want to add this key to our cipher function that is going to encrypt the text that we have, right? So I create a new variable called cipher. Okay, and this will be equal to, actually, I think they have AI, so it's working pretty good. As you can see, it guesses everything I'm going to write. So that's impressive. Okay, so yeah, the cipher is going to be equal to, again, the fairnet library, and then we're going to plug the key right here. So now we have our cipher algorithm. Now you can use now this cipher algorithm with the key generated in order to encrypt and decrypt messages. Okay, so in order to save some time, again, I will just write the line that is going to take the user input. So here we're going to ask the user to write a message that this person wants to encrypt. Okay, so the user is going to write their message here. Now, once they write the message, the first thing we want to do is to encrypt it, right? So I will do encrypt the message. Okay, that's fine. So how do we do that? Let's see if they guessed it. Yeah, so cipher.encrypt.message, exactly. So yeah, right here, this will be our encrypted message. And here we're going to use the cipher that we created, the cipher function. We're going to do .encrypt, so we know that we want to use this cipher for encrypting, and then we're going to put the message. Pretty straightforward. Okay, so once we do that, let's actually display the encrypted message. So I will do print encrypted message, and then we're going to show it. Okay, now after that, let's see if we can actually decrypt the message using the same cipher. Okay, so decrypt message, and obviously the AI also guessed exactly what I was going to write. So here we have decrypted message equals cipher.decrypt, and here we have the decrypted message, as you can see. Okay, so now let's simply print the decrypted message, and this is how we can verify that our file works. Okay, so again, I'm going to just copy this code and paste it in the main file so we can actually run it. All right, I remove this. Okay. Okay, so let's run it. It takes a bit longer because we need to add the cryptography library. Okay, so as you can see now, we're right here, and we're asked to enter the message to encrypt. Okay, so let's do exactly the same message. The sky is blue. Okay, so I run the message, and you can see that here we place the encrypted message. Okay, So this is how it looks when we run the encryption algorithm. Okay, and we can also decrypt the message with our cipher algorithm for which we used our key. Okay, I'm just going to do one more thing. I'm going to print this key so you can actually see how it looks like. You might be interested. Okay, so let's do the sky is blue. Okay, and you can see that the key is right here. Okay, so this is our key that we use for encryption. So when we use a cipher algorithm, obviously we have our key there. So this means that the encrypted message is going to be unique for this communication. If you don't have the key, you cannot unlock the message. Okay, any questions? Is everything clear from the Python codes, the encryptions and the hashing? Okay, if it is clear, you can raise hand on the, on the chat.
So when you get your output there, it shows your text that you entered and then the encrypted message. And the only reason we can decrypt it is because in the last 3 lines there, you're using the cipher.decrypt.
Exactly.
Right. Okay.
So you can imagine this as, let's say this is the sender, right? So this is the sender, okay? So they encrypt the message, and now here we pass through the internet, one router, second router, third router, and so on. Then we reach the receiver, okay? And once we reach them, they have the same key, so they can have the same cipher, right? And they can decrypt the message. If somebody on the way, for example right here, we have an attacker and the attacker gets the message, okay, they will get this, right? They will get this. Actually, this is the key, but you got the idea. So they will get the encrypted message right here. Actually, I'm right. So they'll get the encrypted message. And if they don't have our key, they cannot decrypt it, right? They cannot read it. So even though they got the message, they cannot do anything about it. And for this reason, only the receiver can read it. So this is the whole idea for the decryption.
I would ask another, but I know Srini had a question as well.
Okay, so yeah, who wants to ask next? Oh, I think he just raised the hand to confirm that he understands. So I think you can ask.
Well, I guess in this situation we got our key from Fairnet, from the cryptography library. But
Exactly.
In a different case, we get it from the certificate authority.
Exactly. So you get it exactly from the authority. So imagine this: you need a key, right? You ask the authority to give you a key. It's actually, let me actually show you the figure. That'd be easier. Okay, so since this is symmetric key encryption that we're doing right here, so we're not doing public private key, we're doing symmetric key. So if you ask me for the portion where the key is created, right, you can see that the key is created, and then the key distribution center will have the key, right, of of this communication. So we'll get it from here, okay, and then we're going to be able to, so let's say this is the key of B, right? So B, so here we'll have the key of B, we'll send it to A will encrypt the message with this key, right? It will send it to B, and then B is going to decrypt it with its own key, right? And then when B wants to send a message, so This is if we develop the code further. We need to create another key that is A's key, and then B is going to use the A key to encrypt messages, send it to A, and A will be able to decrypt it. Okay, but for one-side communication, we're going to use the key generated here. Okay, and yes, we're gonna get it from the key distribution center. Okay, any other questions? All right, so guys, now the next thing I'm going to do is I'm going to go over the assignment, because I'm going to release it today. But I mean, everything is explained there pretty straightforward, but I think it's going to be worth it for you if I just go over it and explain a little bit so you can understand. Okay, let me just load the file. Okay, so this is your assignment. This evening, this is going to get released in Blackboard. Okay, so now your assignment is going to be to update the code that we did in our previous lecture. Okay, so I told you there will be relation between the different lectures that we have, and here, you know, you have the program with the different choices. So this is pretty much the description of the program that we already created. Okay, and this is the instructions on how to improve this program. Okay, so the first part, pretty much, if you were listening in the first lecture, you will not need to worry about it too much. It just describes the app that is currently available to you. Okay, which I'm talking about. Let me just show it to you. So this is the app that we did last time, okay, where we have the register function, the login function, and then the main function from which we choose different options, and so on and so on. So this app, you need to modify it, okay, to make it more secure. This is the idea. And to do that, you need to use the things that we learned today. So here is what you need to do. So firstly, you need to generate an encryption key using the farnet function. We just talked about this. So you need to modify the authentication system in the application to securely store passwords using hashing. So you need to hash the passwords before saving them, okay? And once the user types a password, you need to hash that password that the user typed and match it with the one from the database. So we're no longer saving the passwords in the original state, but first we're hashing them and then we're saving. Okay, that way nobody can understand the actual password, but they can you know, they will just see some number. That's it. Also, if the user changes just a small character from the password, then they will get completely different hash. So there is no chance anything to match unless they type exactly the right password. Okay, so then when the user registers, hash the password. This is what I just explained. So when the user registers, hash the password, they enter before comparing it with the actual password stored. Okay, this is what I just explained. Then update the login function to verify the hashes. Okay, so to match the saved hash with the user password that is hashed. Okay, and finally you need to implement encryption on all messages and decrypt them before displaying them to the user to ensure confidentiality. So you can see those messages right here, right? So we have print, registration successful, print, register, and so on. So we want to make sure if somebody gets this print message before reaching the user, okay, they cannot see what's written in there. So what you need to do is to encrypt the message. For example, registration successful, you first encrypt it and then you decrypt it. Okay, this is just an exercise to verify that you can encrypt and decrypt messages. using exactly the same algorithm that I showed you and using the key that you're going to generate in the beginning. Okay, so these are all the tasks. Also, you can see that you get another version of the original code that we created, and there I outlined some of the steps that you need to follow. You can use the same approach as I do, or you can use a different one. This is just how I will do it. Okay, so you can see here step 1, I do something here, then step 2, I show you exactly where you need to do another step. Of course, I'm not going to give you the code, but I will give you some instructions in order to help you with this exercise. Of course, if you have another idea, you can implement your idea. You really don't need to follow those steps. This is just for your help. Okay. Finally, the deliverables. Now, the first one, I just need one file called enhanced authentication.py, which is pretty much your code on how you improved our authentication app. Okay, this is the first deliverable, and the second deliverable, you need to explain the changes made. Okay, and I would want you to explain each change with your own words, describe how you did it, what you used, why you use it, and so on. Okay, so those are going to be the two deliverables. For me, what's important is first, I don't want you to implement exactly like my approach. You can implement my approach, you can implement different one. For me, it doesn't matter. What I want is the code to work properly, and for me, when I run the code, to get the exact outcomes that I expect. Okay, so another important thing for me is to describe a very good what you did inside the modifications that you created. Okay, so that's the assignment, and I mean that's gonna be the final of today's lecture. So do you have any questions first of all for the assignment, something that I didn't explain good or you want more clarification about?
Is the encrypting part, that's once they're logged in, that's when you want them to be able to see decrypted messages, correct?
Yeah, so for the decryption part, so I would say not only for the login, but for everywhere that I'm printing something, right? So, you know, you can, so instead of displaying this as a message here, you can add a variable called registration message, right? And this can be equal to this string here. Okay, and then you can encrypt it and then decrypt it before displaying it, or you can directly decrypt it here, right? So you can do registration message wherever the algorithm is, decrypt, and this is the message that you're going to show. Okay.
Okay. So any printing basically should be
Yes.
encrypted and decrypted.
Yes, yes. So you can do, you know, everywhere, wherever I showed, or you can also create a function that is just a function for encrypting and then decrypting, and then apply this function on every print. It's entirely up to you. Even if you do it the longer way, I don't mind. If there are no more questions, I'm going to release the assignment tonight. If something comes up, please send me an email. If you're not sure about anything, I will try to respond you as soon as possible, so you know what to do. As I said, I'm going to upload the video as well, so you can see how it's done exactly, okay, at any time. So then that's everything for today, guys. Thank you for participating during the lecture. I really hope you learned something interesting today, okay? And I'm going to meet you next week, where we're going to talk about firewalls. Okay? All right. Have a good day and see you next time. Bye.
Thank you.